Hello everyone, my name is Alessandro and I am presenting our study on methodological principles for reproducibility in cloud performance evaluation. Let's start with a situation that we all experience at least once. Let's say that you find a very interesting paper with great experimental results. You would like to reproduce the same results, for example, to compare with your own research. But when you try, you realize that you can't reproduce the same results, either because you don't get the same numbers as the ones presented in the paper, or because you have no idea on how to replicate them. This can be due to several reasons. For example, the code, the datasets, or the infrastructure used in the paper are not publicly available. Another case is that the paper does not fully report the experimental results or the experimental setup. This is a very common problem in science, and it shaped the research methodologies of several disciplines, such as physics, biology, or medicine. The problem of reproducibility is even more complex in the context of cloud computing. For example, running an application twice under different conditions may produce significantly different results. This may be due to hardware or software updates on the cloud side, to the current load on the data center that is executing the application, or to several other reasons. Reproducibility in cloud system is extremely important, not only because it is at the basis of the scientific method, but also because there is a risk that products and services in the market behave differently than advertised or even crash, with a huge impact on the credibility of our field. We started discussing the idea of reproducibility in cloud computing within the SPEC research group. We soon realized that providing a unique definition of reproducibility in this context is extremely challenging. We then decided to focus our attention on the definition of the methodological principles that enable reproducible results in cloud computing. We formulated 3 research questions that guided our research. First, what is the basic set of methodological principles required for conducting a sound experimental evaluation in cloud systems? In our opinion, reproducibility in cloud systems should be driven by a reasonable protocol or by a set of guidelines that need to be defined. Second, can such principles be applied in practice? And finally, how are cloud performance results obtained and reported in the scientific literature? Let's proceed in order. The first question relates to the methodological principles. In this study, we propose 8 principles that cover the basics for reproducibility in cloud computing. P1 and P2 are conceived to capture the variability of the obtainable performance through a suitable experiment design. P3 and P4, on the other hand, are related to the availability of the tools used to produce the experimental results. P5 to P7 are related to the information required to properly report the obtained results. Finally, P8 relates to additional information such as the cost model adopted for the experiments. This responds to our first research question. However, the list of principles is not meant to be complete. It is hard to say that these are the only principles required. Several additional principles can be added to this list. However, when we tried to add new principles, they were either special cases of the proposed ones or application specific. Future work will be devoted to extend these principles. Going to the second research question, we applied the proposed principles to a representative showcase in cloud computing, the performance evaluation of an autoscaling application. We conducted the experiments and reported the results according to the given principles. It took less than 2 pages to fully describe the application, the results, and their statistical analysis. This responds to our second question. Can these principles applied in practice? The answer is clearly yes. Finally, we investigated to what extent the proposed principles are applied in already published scientific papers. We selected some of the main cloud computing venues, including both conferences and journals. We analyzed only the papers published in the last 5 years at the time when we started the study, and we were interested only in papers that contained experimental results in cloud environments. After setting such selection criteria, we adopted a systematic literature review approach to analyze the published papers, involving 2 reviewers per paper, in charge of identifying relevant papers matching the selection criteria and of analyzing if the identified principles were present in the paper. The process included also an open discussion phase to consolidate their opinion in case of a disagreement. A summary of the obtained results for the 8 principles is presented in this bar chart. The 2 reviewers are indicated with a blue and red bar. As you may see, in all the principles, there is an almost perfect agreement between the 2 reviewers. The x-axis indicates if the principle is applied, indicated with a Y for yes, partially applied, indicated with a P for partially, or not applied at all, indicated with an N for no. The y-axis indicates the percentages of the analyzed papers. In the highlighted graphs, more than 50% of the analyzed papers do not apply the principle. This is true for 5 out of 8 of the proposed principles, and it definitely is not a good sign. Only the principle 3 and 7 are applied in practice in more than 50% of the analyzed papers. Note, however, that P3 and P7 just require the description of the experimental setup and the presence of the measurement units when required. The fact that the percentage of yes, even for such simple principles, is not 100% is a worrying sign. A more thorough discussion on these results can be found in the paper. Concluding, in this work we presented a set of 8 principles for improving the performance evaluation in cloud computing. We showed how such principles can be applied in practice on an autoscaling application scenario, and finally, we showed that the published scientific literature is not extensively applying the proposed principles when conducting and reporting experimental evaluations in cloud environments. In the future, we will investigate a possible extension of the proposed set of principles, possibly covering domain-specific applications. We are also reflecting as a community on potential actions that we can take to improve the reproducibility of our research. The take-home message of this presentation is that making cloud results accessible and reproducible to the research community is important for growing and advancing science. I thank you all for the attention, and I'm really happy to take any question.